Welcome back to 6-Minute Statistics. In this video, I'm going to take a deeper dive into the inside probability normal table. In another video, I introduced normal distributions to you, and I mentioned that there were two types of probability tables: cumulative probabilities, which I've covered in another video, and the inside probability table. If that's the table that's going to work for you, hang on with me for 6 more minutes, and I'll show you how it works. Let's go!
Give me 6 minutes, and I'll teach you something new. Now, let's get to work.
Hey there, Mark here from 6-Minute Statistics, and I'm so glad you're back for another installment of the Normal Probability series. In this video, I want to take a look at inside probabilities. In the inside probability table, now the table is going to give us the probability inside, meaning between the z-value we look up and the mean value of 0. While there's a decent chance you'll be able to see how these two tables are related, it's really not important that you do. The main thing is that you can work with one or the other of these tables very, very well so that you can solve all normal probabilities that come your way. All right, so let's talk about inside probabilities. A couple of ground rules to start. The standard normal distribution is a symmetric curve centered at the value 0 with a standard deviation of 1. This means the probability of 0.5 lies below the mean and 0.5 lies above the mean. Now let's look at the inside table. Like the cumulative table, this table also has two main parts. The outside row and column of the table are where we locate the z-score or z-value that we're interested in. These values are given to 2 decimal places. For instance, if I want to look up the value z equal to 1.05, I go down the left-hand column until I reach the value of 1.00, and then I go across the top row till I get to the value 0.05. Putting the 1.00 and the 0.05 together brings me to the z-value of 1.05. That's the first part. By matching this column and row up, we see a 4-digit decimal that we'll refer to as the inside probability. This is the probability that's going to be between the z-score I looked up, the 1.05 in this case, and the mean value of 0. Now we'll notice, because the normal distribution is a symmetric curve around its mean of 0, this table works for both positive z-scores and negative z-scores. This probability would be exactly the same value for the probability between 0 and a negative 1.05. Very important to note, while the z-scores can be positive or negative, the probabilities cannot. Probabilities have to be positive values. In order for us to be working with the inside probability table, we need to be working with a standard normal distribution that has a mean of 0 and a standard deviation of 1. I want to use that distribution to solve 3 questions. First, find the probability z is less than the z-score 1.23. Second, find the probability z is greater than 1.23. And finally, third, let's find the probability that the standard normal random variable z is between a z-score of negative 0.25 and positive 0.55. Let's begin with the first problem. The probability z is less than 1.23. By finding the row and column that match up for the z-score of 1.23, we're going to see that the probability is given as 0.3907. Now remember, that's the probability between 0 and 1.23. If I want the probability z is less than, I also have to include the probability that's below the mean of 0, which we've already said is 0.5. So to find the probability z is less than 1.23, I take the tabled value of 0.3907 and add 0.5 to it. I should note that that's also going to be the probability that the standard normal random variable z is greater than a negative 1.23. See how that works? This time I'd be on the left-hand side of the curve, and I take the 0.3907 between 0 and negative 1.23 and add the 0.5 from the other side. So if I have a 0.8907 that's less than 1.23, what's the probability above it? Well, again, we go back to what we know. The total area under the curve, or probability, is 1, so the probability above 1.23 would have to be 1 minus the 0.8907. Now, if I didn't know the 0.8907, I would go to the table, I would find the 0.3907 number that's between 0 and 1.23, and I can subtract that from 0.5. Why not 1? Because I'm just working with half the curve that's above the mean of 0. So that's a greater than probability. We've looked at a less than or equal to probability. How about the in-between probability? Well, in this case, I have to look up 2 z-scores in my table. By looking up the z-score of negative 0.25, I see the probability 0.0987. Likewise, by looking up the z-score of 0.55, I see the probability 0.2088. Now, what do I do with them? Well, do I add them? Do I subtract them? It's going to depend upon where the z-scores are located. If they're located on opposite sides of the mean, as they are in this case, we're going to add those numbers together and get 0.3075. Whenever we have z-scores on opposite sides of the mean, those inside probabilities can be added together. All right, these three problems are the same three problems I looked at when I showed you how to work with the cumulative table. Let me give you one more. What if instead of a negative 0.25, what if that second z-score was a positive 0.25? Find the probability z is between a positive 0.25 and a positive 0.55. Well, in this case, we'd have exactly the same probabilities from the table. We'd have the 0.0987 from when looking up the z-score 0.25. We'd have the probability of 0.2088 from looking up the z-score of 0.55. But in this case, rather than adding them together, we would subtract them. We would take the 0.2088 and subtract the 0.0987 to get our answer. So when you have z-scores that are on the same side of the mean, we subtract the probabilities. When you have z-scores on opposite sides of the mean, we add them together. And in a nutshell, that's how the inside probability table works. Again, it's not important that you know how to both use the inside and the cumulative table, but it is important you know how to use one of those tables really, really well. Our next step then is to say, all right, this is great for standard normal distributions, but what about other normal curves? What if I have a different value of the mean and a different value of standard deviation? Turns out all those other normal curves can be solved running them through the standard normal distribution. But that, my friends, is for another video. In it, I'm going to show you how we work with other normal curves, and I'm going to solve it using both the cumulative table and the inside probability. For now, your job is to become masters of the inside probability table. Not sure why I said it like that, but you get the idea. Or in other words, it's time for you to get to work. So long.